Okay, so proofs with special quadrilaterals, video notes 5.5. Now, these notes are going to seem like quite a bit. I'm going to be very honest with you. Tomorrow in class, we are going to be working on proofs. I want you to bear in mind that to write proofs it takes time, okay? It takes time, it takes a lot of thought, and it also takes a lot of practice. So the more practice you get, the better you will get at it, okay? I'm just going to review these proofs with you. You're going to do one on your own or try your very best, and then you're just going to go ahead and that'll be it, okay? So we're going to go through two guided proofs together, and you're going to do one on your own. Try the best that you can, all right? So it says here, we are going to be able to prove statements through two-column proofs given a figure is a parallelogram, rectangle, rhombus, or square. So what we're doing is we're using the properties of a parallelogram and applying them to triangles that are within parallelograms, okay? So for example, we have parallelogram A, B, C, D. Because they gave us this information, what I typically do is I just immediately, based on the properties of a parallelogram, one being that opposite sides are parallel to each other, opposite sides, the second one being that opposite sides are congruent to each other, third one, diagonals bisect each other, right? So that means that I have 3 tick marks here, I have 3 tick marks here, I have 4 tick marks here, and I have 4 tick marks here. Okay, so essentially what I do is I mark up the figure, and I always tell you guys to do that. Mark it up so that you start to have all this information, okay? So my first statement is that ABCD is a parallelogram, okay? Now, I'm trying to prove that these two angles, angle ACD, so ACD. So I'm trying to prove that this angle right here, ACD, is congruent to CAB, this angle right here. Okay, so I'm trying to prove that these are congruent. All right. So the second statement that I made is that CAD, this triangle here, right, or rather this angle here, is congruent to ACB, all right? So the reason for that is alternate interior angles are congruent, okay? So these two angles are congruent to each other. And by that same theory, by that same token, these two angles are going to be congruent to each other, because if this is your transversal, these are your parallel lines, then of course, if these two angles are congruent, then those two, because they're both a set of alternate interior angles. But we're going to go a little further, and I'm going to explain to you why in a second. All right, you can't stop the proof right there. All right, then we state that ADB, angle ADB, is congruent to angle CBA. So this angle right here is congruent to this angle right here. All right? And then using the reflexive property, so think about it as, the way we're looking at it is we're looking at these two triangles right here. So this whole triangle here and this whole triangle here, okay? All right. So, because we're stating that this is true, that this is congruent to that, because one of the properties of parallelograms is that opposite angles in a parallelogram are congruent, okay? So then our next statement is that AC is congruent to AC because of the reflexive property. They share that side. It's a shared side, okay? And then triangle ADC is congruent to triangle CAB. So we did have to prove that the triangles themselves were congruent, okay, before we could just go ahead and say that ACD is congruent to CAB. But how are the triangles congruent? Well, we have a side or rather, we have an angle, and a side, okay? And the side being this right here. So we have an angle, and a side. So that's a little bit difficult to see, I guess, given the diagram. I'll show it to you again. Angle, side. Same thing here. Angle, side. Okay? Now, we're going to go through proofs a lot tomorrow. So, again, I know that this is challenging, and I may not be explaining it in a way that is the most understandable for you. But, again, it does take time, and we're going to work to get very comfortable with proofs. Now, you're going to see this statement, which you haven't seen before, or maybe perhaps you have, and it states that corresponding parts of congruent triangles are congruent. What does that mean? It means that if I can prove that these two triangles are congruent to each other, then I can prove that any corresponding part or any corresponding parts of those triangles are congruent as well. That's what CPCTC states. It means that once I prove that the triangles themselves are congruent, then I can prove that any corresponding parts are also. Okay? So the final statement, notice here we're not trying to prove, the proof is not asking us to prove that the two triangles are congruent, even though we do have to do that. It is asking us to prove that these two angles are congruent to each other. Okay? And we did that by proving the triangle's congruent, and then finally the last statement proves that the angles, being corresponding parts, are also. Let's give it another try with number 2, which is a longer proof. So here's the whole thing, so you can copy it down as I review it. States here, 2, given that DEFG is a square, and that segment DJ is congruent to segment EK. Prove, and again, we're being asked to prove that angles are congruent, not that the triangles themselves are, even though we are going to have to prove that the triangles are congruent before we can prove that the angles are, okay? So the first statement they give us is that this is a square, okay? And that's our given. They also tell us that these two segments are congruent, all right? Now, because I know that DEFG is a square, I went ahead and I started marking up the diagram, and I filled in these 4 right angles, and I also indicated that all the sides are congruent to each other. Okay, and so the statement DG is, I made the statement DG is congruent to EF, because essentially what I'm trying to do here is I'm trying to prove that these two triangles are congruent. That's what I'm doing, okay? So DG is congruent to EF. This side is congruent to that side because squares have 4 congruent sides. That's my reason. So I've already proven we already have a side that's congruent to a side and another side that's congruent to another side. Then my next statement is that angle D is congruent to angle E. Why is that? Because squares have 4 congruent 90-degree angles. Okay? So now I have proven through side, angle, side, angle, side, that the triangles JDC and KEF are congruent. So then, by CPCTC, corresponding parts of congruent triangles are congruent, okay? These are congruent triangles. Their corresponding parts are congruent. And those corresponding parts are angle 5 and angle 6. Finally, the last statement that I'm making here is that angle 1 is congruent to angle 2. Why? Because if you think about it, this is a linear pair. If angle 5 is, say, 50 degrees and angle 6 is 50 degrees, then, of course, they're congruent, and we stated that, right? That means that angle 1 is going to be 130, and angle 2 is also going to be 130. So if angles 5 and 6 are congruent, then the measures of their adjacent angles or linear pairs are also congruent. Okay? Little long-winded. Again, we're going to be practicing this all day tomorrow. Just make sure you have this down because it helps you just kind of see how your proof is supposed to flow. The next page is a proof that you're going to be trying on your own. Now, I don't want to hear, Ms. Clark, I didn't understand, I didn't get it, it didn't make sense. I want you to take it upon yourself to try it. Try your best. Write some logical statements, some logical reasons, and really just think it through, okay? That is for you to do, and that's your given. That's what you're trying to prove, that ADE is isosceles, okay? Good luck, and I will see you tomorrow in class. Adios.